Welcome back, everyone. It's week 2 of the EigenLayer Hackathon. So excited to have you here. Good to see you all again. And Ken, please take the floor. The hour is yours. We're so excited to hear what you have to teach us today.
Awesome. Great. Yeah, I'll get into it. So, hey everybody, my name is Ken Miyachi. I work at Polymer Labs, and I'm going to be giving, an introduction to Polymer today and discussing briefly how it integrates with EigenLayer and AVSs. So, feel free to definitely ask questions, make this interactive. I'll stop and try to answer questions, but I often think it's better if these talks are interactive and can answer questions on the fly. It often helps other people participating. So Polymer is the interoperability hub of Ethereum. We're starting with OP stack chains, which includes Optimism and Base, and will eventually expand to other rollup ecosystems such as Arbitrum, and then even beyond the Ethereum ecosystem. So what is Polymer? Polymer, let's see, the term port city was defined by Ethan Buckman and Sam Hart. And what it means in terms of blockchain is it's a clearinghouse for trade routes to the largest economies. And then, in blockchain terms, it's the largest blockchain protocols. And an example is you can think of is Alexandria, Egypt, which was one of the largest ancient port cities connecting Europe, Africa, and Asia. And then a more modern example is the port of Los Angeles, which is the largest port in the United States. It connects trade internationally to a variety of the different trade routes that are, domestic with inside the US. And so our vision is to be this port city connecting Ethereum to all these different ecosystems. And we're going to be starting with, OP stack rollups. So there's a variety of interoperability protocols and bridges out there. And what makes Polymers technology unique and kind of how do we conduct our interoperability solution? The two main pillars of Polymers technology is IBC transport and Ethereum settlement. So Polymer is extending the interblockchain communication protocol to all chains that are in Polymer's ecosystem. Any chain that is connected or integrates Polymer will now have access to IBC level transport execution. And then the second piece is that's really on the transport side of things. On the security side of things, it uses Ethereum settlement. So Polymer has a light client for OP stack rollups, which checks the proposals and the transactions against Ethereum itself. And Polymer itself is also an OP stack rollup, which settles on Ethereum. So it essentially uses Ethereum as its source of truth for all transactions for cross-chain communication. What this essentially does is it extends the Ethereum native bridge for rollup to rollup communication. So this has a really interesting value proposition to interoperability because it doesn't introduce any additional security or trust assumptions you need for secure cross-chain communication. By extending the native bridge, you're relying on Ethereum for both the state of your source chain that you're sending a transaction on and your destination that you're receiving a transaction on to ensure that there is secure communication when you're passing messages across different chains. And so for anyone who's not familiar with IBC, like why is IBC important? So IBC was first implemented by the Cosmos ecosystem, and Cosmos chains natively implement IBC to be able to transact cross-chain with different Cosmos built chains. That wasn't a principle like a value proposition or feature built into Ethereum chains. And so trying to bring IBC over to the Ethereum ecosystem is what we're trying to do. And what is really great about IBC is first, the number of exploits or vulnerabilities that has occurred over, since it came into production. And so now it's already been over 3+ years and there has been 0 exploits in the IBC protocol, which is really amazing. and it shows not only the resiliency but also the maturity of the technology as well. It's not like it's brand new and it hasn't had any vulnerabilities, but it's been around for a very long time and has shown that it is extremely secure and reliable. And so what makes it reliable is really this concept of acknowledgements. Many bridges, right, oftentimes rely on purely off-chain communication to send a packet or information from the source chain to the destination chain. I just saw a question rolling. Hey, AJ, IBC stands for Inter-Blockchain Communication Protocol. And so going back into why IBC is important, right? What IBC does is it has this concept of, yes, you send a packet from a source to destination, just like any other bridge or interoperability protocol, but then you also have a concept of receiving the packet or the information, and upon the destination chain or application receiving it, sending an acknowledgement back to the source application or the source chain. And so this really kind of creates a very foolproof mechanism to ensure that packets don't get lost or exploits don't occur, because right, information needs to go from the source to the destination and back to the source to be able to be fully verified throughout the life cycle of cross-chain communication. And so, right, IBC is native to Cosmos. We're doing this on Ethereum. Like, how does Polymer bring IBC to Ethereum? So there's a concept called virtual IBC, which are smart contracts that are written on Solidity, which decouples the transport layer of IBC from the execution of the application from both Polymer and the chains that are trying to do cross-chain messaging. And the purpose of creating the IBC was to enable IBC native features on non-IBC native chains, such as Ethereum. And so there's a variety of different concepts that virtual IBC implements, including clients, which verify any arbitrary logic that can be transacted across chains, connections, which are a pair of clients, which represent connectivity between source and destination chains, channels, which are application-specific communication paths for any number of these different connections, and then last but not least, relayers, which are kind of off-chain actors which observe these channel transactions and commitments and relay them between the different chains. And maybe last but not least, there's also a concept called packets, which is essentially what virtual IBC is transporting between the different chains. Packets are really just any application data that is flowing over the IBC channel. So you can think of a packet, you could transfer, ERC20 tokens, you could transfer, any arbitrary logic, whether it be numbers, even, strings, if you just want to pass messages between applications. Okay, going into a little more detail here. So a lot of existing bridging solutions today operate at the application level with endpoints directly connected to each of the chain. And there's a variety of complications that arise when this type of security model is implemented, because what you really want here is to create performant applications, right? You can't have your transaction from chain A to chain B take 5 years or even a day, right? It's just much too long. So we need to create performant applications, and a lot of these current bridge solutions rely on a concept of pre-confirmed transactions to be able to implement this feature of performance and high throughput. And so there's a variety of different ways that these applications do it, but a lot of them introduce, they introduce essentially different security risks, and there's different security models associated with a variety of these different pre-confirmation solutions. And so in the modular world, maybe before I go into this, could you please share doc? Yeah. Oh, thank you, Philippe. Yeah, I can share documents after the presentation, Katya, and I'll also make sure to provide. There'll be links at the end of the document that will be shared with everyone as well. So, kind of going over into this, like this kind of concept of what the security model of current bridges are. There is an ongoing specialization and modularity of the rollup stack, right? Optimistic fraud proofs, new data availability layers, new sequencing layers, and a lot of these pre-confirmation solutions rely on this kind of modular or specialized components of the rollup stack to be able to kind of create performant cross-chain transactions. And so when you think about, right, reorgs happening with fraud proofs, right? A fraud proof is confirmed and then there needs to be a reorg on the rollup. Or if there is an issue with the batches and a reorg needs to occur because the batch wasn't sequenced correctly, etc. Or even like finality, wasn't correctly established and there needs to be a reorg there. There's all these different components that as the rollup ecosystem becomes more and more specialized and more modular with these different specialized components, the likelihood of all of these different components staying completely in sync becomes less and less likely. And so what Ethereum does, or what Polymer does, is rely on Ethereum for its kind of source of truth and consistent view across all those different modular components of the rollup stack. And so we think that this is really the kind of long-term solution to solving this problem, and it will be very difficult to rely on any of these individual components for verification of cross-chain transactions moving forward. And they'll introduce security risk and be issues with reorgs or security down the line. And so, like, yeah, maybe just going briefly, helping understand this diagram here, right? If you rely on, right, sequencer pre-confirmations, this can be done in 3 to 10 seconds, but essentially it introduces significant more risk. If you rely on basically safer, once finality is reached by the sequencer pre-confirmations, then it's in 2 to 4 minutes. If you're relying on finalized sequencer pre-confirmations, right, it takes around 15 minutes, and it's even more secure than the previous two. And then if you're relying on verified soft confirmations, which it's written to the Ethereum blockchain, but right, if specifically with Optimism, there's a 1-week fraud-proof window. It's anywhere from 1 hour to 7 days. And so as you get more and more secure, right, the time for confirmation, verification gets slower and slower, and right, you need to balance both security and performance when you're thinking about how you handle cross-chain communication. And so describing Polymer Solution, one example that we like to use that is more of a Web 2 example is service meshes. So a service mesh is a software layer that handles communication between microservices or applications. And you can think of Polymer as being the service mesh for the Ethereum ecosystem. With the help of IBC, what it establishes is communication policies and status flow and communication throughout these different components. Can you explain in layman terms? Well, maybe if you could clarify, exactly what I can try to explain a little further. And so what I mean by this service mesh piece is, as I mentioned before, in this rollup kind of world, there's more and more specialized components and architecture, and there's also this shift towards even the emergence of L3s, where there'll be more and more blockchains. So in this world, Ethereum, the Ethereum L1 like assumes the role of the fundamental security. L2s really focus on scaling and providing more transactional throughput and block space, and L3s focus on application-specific logic. As more and more L2s pop up and more L3s are expanded on top of that, the need for communication between these different layers will be extremely, extremely important. And so Polymer will be the connective tissue or the service mesh that enables communication between the diverse array of L2s and L3s. So kind of when I was talking about Ethereum settlement, like beyond the service mesh piece is really this, how it routes information cross-chain. And so, as I mentioned before, it relies on Ethereum as the source of truth for all of its kind of cross-chain communication. And so, Polymer reads the rollup state of all of the chains connected to Polymer through the Ethereum L1. So every transaction that occurs on any L2, Polymer is reading that information from Ethereum itself so it knows it's secure and correct. Polymer itself is also an L2 and writes and reads its state from the Ethereum blockchain as well. And so what this does is it introduces a novel approach to interoperability with what is called in the Cosmos ecosystem an hub and spoke model. So essentially, let's say this is chain A and chain B are both connected to Polymer, right? In other interoperability solutions, if you are chain C trying to now create, interoperability between these two chains, you need to create a connection to this first chain and then another connection to this second chain. In Polymer, chain C would be integrated by simply just connecting to Polymer, and you would have native access to interop and send packages and receive packages or receive messages from both chain A and chain B. Okay, so going into a little more of the network topology, the network architecture of Polymer. So verification is separated from the coordination, which enables dApp developers a lot of control over how they perform cross-chain communication. And so this is a lot different than other interoperability protocols, but it's very similar to the microservice example that I provided previously. And so there's a couple different ways for dApp developers to create bridges or can create channels to different chains or applications on cross chains. And one way they can do it is create application-specific bridges via virtual pathways over Polymer that create a personalized channel, a personalized conduit for application-specific traffic. So let's say, for example, that you have a cross-chain DEX application and you want to create a specific channel to send your tokens on your specific application from base to optimism. You can create a personalized channel for your application that essentially reserves traffic throughout the network that no other application can use in Polymer, that allows for just packets between your application to be sent to and from optimism and base. You can also use something called a universal channel, which is essentially a channel connection between two specific chains that can be used by any application on each specific chain. And so this gives dApp developers a lot of ownership and control over the exact type of functionality they want for their cross-chain communication. You can either choose to have basically an application-specific channel that only your application can use, or you can use something out of the box that all applications are using, but doesn't require you to create any application-specific infrastructure for you to send these messages. And then it also creates exclusivity for performance and security optimization. So not only when you create kind of a channel that only your application uses, it has this property of really, providing exclusivity of traffic, but also no other application can try to like DDoS your channel or slow down your channel with a bunch of different transactions, etc. Why do you use layer 0? Great question, Lewis. So this is the relayer portion of the diagram here, and a lot of different solutions can be used here. You can use any relayer, actually. Layer 0 is just one example, and what really this graphic was meant to highlight is that there's a lot of different bridges or interoperability solutions out there, but Polymer, because of its architecture, can be integrated as compatible with a lot of these different solutions. So this could be replaced with Wormhole. Polymer has its own relayers as well, so it can be replaced with any of those. Is there a limit to the size of the packets? I believe the packet size limit, there's no explicit limit on packet size from my understanding. The limit would be in gas costs associated with sending the packets on each chain. So right, you'll have limit for both computation and storage of what you're going to be, the computation performed on the packet, and how much of that information you're going to be storing on either the source and the destination chain, and it has to fit in the gas limit of the source and destination chains. So just kind of hammering home the idea of 2 slides ago of like really this hub and spoke model. But what Polymer is an aggregated source of translating information between rollups. And how it does this is it packages all the state transitions of the L2 into commitments that can be read from Ethereum for Polymer-enabled or IBC compatible chains. And then what Polymer does is it's able to verify these transactions and allow for direct rollup to rollup connectivity by ensuring that the state has been verified and transactions can flow securely and efficiently from source chain to destination chain. And what this really creates is Polymer is the aggregated cross-chain state across Ethereum rollups. So for rollups that are connected to Polymer, it's writing information, both non-cross-chain communication and for cross-chain communication, eventually to the Ethereum rollup. All L2s eventually settle on Ethereum. And so Polymer is reading that state from Ethereum of these connected L2s, as well as all these L2s, as well as Polymer itself. And what this really does is create a aggregate or full picture of all the cross-chain state and communication of Ethereum rollups that are connected to Polymer. Okay, so now I'm going to go, I just did a brief introduction of, what is Polymer, but this is the, EigenLayer Encode Hackathon. And so I'm going to now describe what EigenLayer, how does EigenLayer integrate with Polymer? So the first is EigenDA. So EigenDA is EigenLayer's, the first essentially implementation of an AVS for EigenLayer, and it's their data availability solution. Polymer has partnered with EigenLayer to use EigenDA for scalability, also allow enhanced security, but essentially to use EigenDA as a data availability layer for scale and cost of cross-chain transactions. And so this is essentially the first integration of EigenDA, but some of the benefits of this is that, as I mentioned before, something that I've been trying to hit home is that the security model of Polymer really is completely reliant on Ethereum. It doesn't introduce new security models or trust assumptions when creating this cross-chain service, Ethereum service mesh. And so something that's really great about EigenDA is that it also is an Ethereum-centric solution that also settles eventually to Ethereum. So by using EigenDA, Polymer can maintain the trust model of relying on Ethereum as the source of truth. And then it really allows cross-chain transactions to scale and improves the cost of these as well. And so Polymer is working on integrating with EigenDA, and then EigenLayer is working on creating a integration with the OP stack, which will allow us to create this solution. There are more use cases of EigenLayer AVS in Polymer beyond just as a DA layer for cross-chain transactions. And so what EigenLayer's AVS technology enables is really for any validator operator to monetize computational resources off-chain. And there's a lot of different potential use cases that can be implemented for Polymer. So one of them is this concept of multi-sig authorization of AVS node operators. So in this case, you could create registry contracts on both your source and your destination chain, and then have basically the operators register on those chains and sign transactions whenever a cross-chain transaction was occurring. And so this adds a multi-sig layer on top of Polymer that could improve security of possibly very high, highly critical, high-value transactions that you want additional security benefits around. The other potential use case that we came up with was like batching services. So this is more on the scaling route, but you can think of an AVS or an AVS operator kind of with the duty of batching transactions of cross-chain packets so that it can improve the scalability and efficiency of cross-chain communication. And so if you're doing, if you're sending, very high TPS, oftentimes a common scalability solution is to batch the transactions so that they can be processed more efficiently. And then in this case, right, the AVS would be in charge of batching the transactions to send across chain to improve the scalability. And then another really interesting potential solution for an AVS would be a data indexing authorization service. So something like a cross-chain, off-chain database, you could index a variety of different rollups, and this AVS would be kind of authorized for verifying the data is correct and then writing the data to this off-chain service that could be, essentially like an off-chain database of multiple different rollups and their cross-chain activity. So these are just a couple of different examples that you could use, an EigenLayer AVS for within Polymer, but there's a lot of really interesting use cases, but I think a lot of them are focused on scalability, and then some of them are focused on also enhancing the security. And then so I know that someone asked for some resources, but so these are, I think this is a variety of different information, but it contains the Polymer's white paper. The blog has a lot of really interesting information about kind of some of our most recent partnerships, including with EigenLayer, as well as kind of technical writing, very simply explained about some of the Polymers technology. And then there's some different stuff about IBC specifically, so you can really understand kind of some of the core technology of how Polymer is built and some of the core components of Polymer itself. And so, I think I ran through this a little fast. There wasn't a lot of questions. I'm a little too quick, but I can open it up for questions. So would love any questions. And then also here, definitely, our Discord is where we do a lot of our communication. And so if you have any technical questions or want to get involved in our community, Discord is definitely the place to start, and there's a lot of people there working on a variety of different things. And then our GitHub is right here, and then definitely please follow us on Twitter, and don't hesitate to also reach out to myself. This is my Telegram and Twitter accounts. Does Polymer have any main competitors? Yeah, AJ, great question. So, right, there are a variety of different, I would say, interoperability solutions or bridging solutions out there. So there is a decent amount. I don't know if I would call it direct competitors, but there are a lot of different, right, bridging solutions. It's kind of a, I don't want to say it's an obvious problem, but it's a common problem, right? Especially, like, I think a lot of people talk about the fragmentation of the Ethereum ecosystem all the time. So you can think of other solutions: Layer Zero, Wormhole, Axelar, Hyperlane, and I think more and more are popping up. But there's a lot of different solutions for cross-chain messaging. Is yours most efficient? So I think efficiency is a broad, kind of like a broad term, where we think Polymer has advantages in is both in, I think, control and security. So if you do want an extremely efficient, cross-chain interoperability solution to be sent, then it allows you to both kind of basically choose what level of security versus essentially latency that you want. And then also, in terms of efficiency, where we think it's much more efficient is in the concept of that hub and spoke model that I talked about. So with other interoperability solutions, you often need to connect to every individual chain that you're trying to interact with, where if you want to connect to all of the chains that are integrated with Polymer, if you just connect with Polymer, you have that connectivity built from a single connection. And that's, I think, improves, I would say, the onboard efficiency of creating an interoperability, like an interop compatible application. What happens if sending pack fails? How long does the source chain have to wait for the acknowledgement? Yeah, that's another great question. So this kind of depends on what you're using for your verification. So I think it can go from as fast as seconds, and then it can be all the way up to, I believe, like 7 days, right? If you're relying on Ethereum finality. So I think in, like, right, the most secure, slowest mechanism, what you're waiting for is, like, essentially the cross-chain packet to be sent, that to be written to Ethereum, and then the fraud proof to pass, right, in order to verify, and then for the acknowledgement to be sent back. And so that's an extremely long time. But then there's essentially verification techniques that you can use to do this much faster in the like level of seconds. Is there any way to interact with EigenDA from Polymer? Currently, I don't believe there is an active implementation of a way to interact with EigenDA from Polymer. But yeah, I think definitely really excited about this solution. We have, like, a bunch of ideas of, like, where to start with this as a hackathon project. So if you guys are interested, if anyone is interested in working on, like, kind of an EigenDA, an Eigen AVS type solution for Polymer, definitely reach out, and we can help. We want to do cross-chain processing in our own app. Got it. Okay. For Zach's question, so you would be able to do this. Right now, Polymer isn't integrated with Arbitrum. That is on the roadmap, but currently Polymer supports certain OP stack L2s. And so if the chains that you're looking to do cross-chain processing with are integrated with Polymer, you would be able to do this very, very simply. But currently doesn't support Arbitrum. So another great question, AJ. Polymer is kind of DA modular agnostic, right? really you can use any DA solution. Polymer, the goal of Polymer is to integrate with any DA solution, just like it is to integrate with any type of like relay or bridge. And so um, we don't have a, I would say, preferred DA service, but EigenLayer is right. They're partners of ours. We're very aligned with what they do. We think their DA solution is really, really great, and we're going to be using EigenDA. I don't believe so. I don't know. I would have to get back to you on the details, whether like any like liquid restaking, but yeah, I've got anything other than Ethereum. I'm not sure I understand the question, AJ. What is the role of polymers? So yeah, I would say the role of Polymer smart contracts is essentially, I'd say like a core of it is really that concept that I talked about of the virtual IBC. So it essentially is an implementation of IBC in Solidity that allows for the, you know, the logic of IBC to be implemented for Ethereum or Solidity contracts. And that kind of includes this process of, right, sending, receiving, and acknowledging packets, and also creating and establishing channels. Among a variety of other things, but really creating this like transport logic that is extremely secure and verifiable. So let's see, not that is a dependent. It's dependent on how you want to use Polymer itself. So if you are interacting, like let's say you have contracts, an application that is on both Optimism and Base, Polymer contracts are already, or the VIBC contracts are already deployed on both testnet, Optimism, and Base. And so you would be able to, if you just interact with the Polymer contracts, then you'd be able to send cross-chain packets through those different chains. But if you wanted to establish it, like if you want to integrate Polymer on your new chain, then yes, you would need to deploy the VIBC contracts. Is gas needed to query data? No, yeah, if you're just querying data, I guess if you're querying cross-chain data, yes, some gas would be required. But if you're just querying, like let's say if you're just querying the Polymer contract, like or the VIBC contracts, then no, it wouldn't. So like, but right, if you're, let's say like you're on chain A and you want to query data on chain B and have it sent back, right? Essentially, you'd be changing the state of chain A because you're saying, hey, like write a transaction that is sent, cross chain. If you deploy these contracts to it. So if you have an app chain, are you referring to like a Cosmos app chain? Yeah, so in that case, you wouldn't need to deploy Polymer contracts because, right, your app chain would have IBC natively, built into it by default. And so at some point, you would be able to interact with Polymer contracts directly, or Polymer directly, to be able to interact with the rollups that were connected. Yeah, that's another great question. So something I'd recommend checking out is this like IBC app Solidity template. So this is kind of like our like a starter code. And so I think I've seen a lot of people, and then this is also, I actually should put this, I need to add this to the so that's like the starter, and then this is like awesome Polymer repo, but it has like a bunch of community apps that people have built. And so really, if like you have an existing app, the process that I see of like integrating with Polymer is essentially like, I think like using those contracts, and then what you would do is you would try to inherit some functionality from the VIBC contracts and then implement the logic for, you essentially need to do sending, receiving, and acknowledging packets is the very high level simplified process of how you integrate VIBC into your application. Yeah, yeah. There are, so like, I mean, that demo, let me see if I can bring it up. But yeah, like the in that IBC app Solidity template, yeah, like Thomas, another team member, made it really easy to like set up, and you can see the process of channel creation and packet sending, really seamlessly from the command line, which is, yeah, super, super helpful. Okay, so this is the repo that what I'm going to demo for everybody. And essentially, I need to go to the actual repo. So what this is a template with VIBC integrated, and what it has is the quick start guide is essentially a way for you to deploy a very simple counter smart contract that essentially keeps it countersynced on two chains between base and optimism. Create a custom channel, as I mentioned, of like establishing, hey, only this application will be able to use that channel, and then visualize a packet being sent over that channel. And so maybe just briefly, I can look through the contract. So what you'll see here, right? Like if you were to have like a non-cross-chain application, a non-interoperable, like a cross-chain interoperable application, right? This would essentially be, it's made to be a very simple demo. This is the core logic of the application. You have a counter map, and then you have an increment function, as well as a reset function, which really all this does is increments the counter variable, right? And so the core of the logic in this application to essentially make this Polymer compatible is to integrate VIBC contracts. And so what you're doing here is you're saying, hey, when you deploy this X counter contract, actually inherit from this custom channel IBC application, which is essentially in the base contracts up here, and you're going to be deploying it with a dispatcher function, which is the VIBC contract, which sends packets from source chain to destination chain and also receives them. And then these are the three functions that you really need to implement to create this cross-chain functionality, which is send packet, which basically increments, sends the payload, and then adds additional information such as timeout, etc. You define how you're going to receive the packet on the destination chain, which is essentially saying, hey, I need to decode this information, get whoever sent the message, and then increment it on the destination chain. And then the acknowledgement is saying, hey, you're basically sending the counter variable back to the source chain. And what it's saying is, hey, decode that information. If the counter information that was sent back doesn't equal the variable that's on the source chain, then reset it. And so now I'll go through. That was a pretty fast way of going through that logic. But essentially, what you need to implement is the logic to send, receive, and acknowledge the information that you're being sent between the two chains. And so let's see if I can. I'm gonna just do this command right here, and so I'll try to walk you through what's happening here. And so at the beginning, what this is doing right now is it's first deploying the contracts to each chain individually. So this deployed X counter to optimism, and this deployed the same contract to base, and it's giving you the specific addresses here. And so now we're working on creating channels between those two applications. This might take a little bit. And so what this is doing is essentially, this is called the channel handshake, but essentially, what I mentioned with universal channels and custom channels, it is establishing this custom channel between the two applications, so that only in each channel is given a specific identifier. You can see on our testnet, the channel ID that we have here is 40,480. So there's a decent amount of channels. And this should finish up soon. And so this is basically the process of initializing, trying to open it, acknowledging, and then eventually we'll get confirmed. And what's really great about this script that Thomas, one of my colleagues, wrote is that there's a variety of different configurations that you have when you're you're setting up what channels to use and what your destination application is. And this script automatically kind of sets these configurations for you when you're in the process of deploying, creating channels, and sending packets. So you see now it's sending a packet. So, okay, so what you're seeing here, right? The packet was originally sent from Optimism to Base. These are the different configurations that I was talking about. You can see that you can explore, you can look at a block explorer with this URL. This is the transaction hash, which, you basically just click in. It's the transaction hash on the block explorer. These are the different configurations I was talking about. So it's like, hey, yes, this is going to Base, but what is the port address that you need to connect to, right? What is the channel that it's going to be using to send this through? The sequence is essentially the counter of the number of packets being sent on a specific channel. So, right, this was the first packet being sent on the channel we just sent up, so the sequence is 1. Then this next step is an event that is saying, hey, the packet's now been received on Base, right? And it has kind of similar configuration variables as well as transaction hashes. And then, right, this channels are not bidirectional. So, right, the channel from Optimism to Base between these two applications was 40,480, and then the channel from Base to Optimism is 40,481. So, right, the packet is received, it's sent back. When it's saying acknowledgement's written, that is saying, hey, so the packet's received, and now the destination chain is sending the acknowledgement back to Optimism. So you're seeing, right, the received transaction happened on is on Base, and it's actually the same transaction, but it's just a different event, right? And then it's saying, okay, it's kind of completed the Base activities, the Base functions that's happened, and then eventually once it gets received by Optimism, right, it says packet is acknowledged, and then now we have incremented our counter on both Base and Optimism, and they're in sync. And so, yeah, definitely highly recommend trying out the demo. And then if you want to create, if you want to add Polymer to any of your applications, definitely would love to help. And also feel free to submit them either on Awesome Polymer or our forum. Like we have a lot of activity of people creating, the community creating applications that utilize Polymer in really interesting ways.
Awesome. And yeah, Katja has just put in the chat, thank you, this is much more understandable. I'm glad that we had time for a bit of a walkthrough, and I think being able to see it really helps. So thank you so much. I guess we have a few more minutes left. If anyone has any pressing questions, please put them in the chat now quickly. Otherwise, I will begin to wrap up. Pardon me. Cool. Link where to send. Do you mean the link for the demo? If it is for the demo, is it a different link to the ones that you sent previously, Ken?
I'm not. I think it's IB. It's in the chat, but I can also send it again.
I can also. Yeah, I can also. I've saved those, so I'll also post that in Discord as well. Oh, I see. Link for the Discord, for the Polymer Discord. Yeah. Okay. I'll while Ken is getting that up, I'll just quickly answer Katja's question. Do you have any space to connect with the partners and sponsors? Yes, there will be once we kind of start to wrap up the workshops period, but I'm sure you all have burning questions. Ken, I believe you did mention as well the best ways to get in touch, which was Discord, as well as, you can follow Ken on Twitter as well. Have I remembered that correctly?
Yeah.
Awesome.
Yeah, definitely feel free to reach out either personally or the Discord is a really great spot as well. You can get connected with other community members there as well.
Mm-hmm. Cool. And Katja, if there is any particular group that you want to get in contact with and can't seem to find a way to do so, let me know, and I I will try my best to kind of get you the right contact and connection. Awesome. Cool. Well, I think we've used up the full hour. That was awesome. Loads of questions. Well done, guys, for just kind of getting engaged, getting involved. No question is too small. So well done. As always, or as is with this program, we will have another workshop tomorrow. We will be having one every day until Thursday this week. Same time as usual. I'm sure you all have it in your calendars. Tomorrow's workshop, I believe, is with Versatus. So please do come along for that and tune in. But yeah, thank you all so much for coming today. Great questions, great energy. Thank you so much, Ken, for speaking. Any final comments or words to say goodbye?
Yeah, no, thanks everyone for coming out. Really appreciate it. And yeah, look forward to what everyone built.
Awesome. Right. Well, thank you all so much, and I will see you tomorrow. Bye.